We'll be focusing on the milling module today, and maybe the nesting module if needed. So when you select mill, you'll notice that the machining interface shows directly in Rhino. So you have your machining browser over here, and then on the lower half you have the machining objects browser. So you can preload your tool libraries. You can also load the default libraries. You can also build tools and save them to a library. So RhinoCam offers you a variety of different tool types, starting with ball and mills, flat end mills, corner radius, tools for engraving, chamfer, taper, thread mill, face mill. It could also create dovetail tools, lollipop cutters, form tools, user-defined tools. We call them as form tools. And also you have the drill, center drill, reamer, tap bore, and reverse bore.
User-defined ones, can you program your own DXF in there, or how does that work?
Absolutely. You could actually import one of your tools, or if you want to draw something up in here, you can use the tools that you have in Rhinoceros. For example, I could start by creating a user-defined tool by just modeling my cutter profile in here.
Perfect.
And I'm going to go ahead and scale this a little bit. And I can modify all of these tool profile in here. So I'm going to go ahead and create a tool. Now I'm going to basically just join them together. Now once I have this drawn in here, I just got to select it and then go into the tool definition, select user-defined mill, and then click load selected profile, and my tool is defined.
Perfect. Okay, that's good. Yeah.
So you could use these for like engraving or profile cutting operations. So like create the form on the part that you want to accomplish. So that's how you can define user-defined tool. You can also specify your holder properties in here, the holder diameter, holder length, and once you establish, also you can establish your feeds and speeds based on the material type that you're working with, and save them up to the list of tools, and you can add it to your library. So you can create your own library. You can build your library based on a type of machine tools you have, or if you have based on a type of projects you're working on for different types of woodworking applications or metalworking. So you can create tool libraries and save them into RhinoCam. Now we're going to take a look at about 2.5 axis and 3 axis machining. Now since you mentioned about working with cabinets and cabinet designs, we have a module that's integrated into RhinoCam, which will allow you to take a cabinet design and you can basically flatten it out into 2D as well.
Now, if I was to email you a 2D like a DXF right now, could you see if you could nest the DXFs that come out of CapMaster? Or is that not going to work that way?
If you want to email us the DXF file, I can go ahead and import those DXF files into Rhino, and I can show you how to work with it in our nesting module.
Perfect. Okay, just give me 1 sec, then I will...
So what I'm going to do here is first, since you primarily work with cabinets, I'm going to go ahead and import this file, a cabinet design file, that was actually designed in another application. So it's a file format is called a SketchUp file format, as you can see it. So I just imported a part right in here into Rhino. And now these have several flat parts as you see it, right? So they're all primarily flat parts. So we would like to, program these holes and dados and pockets on these flat panels and then machine them. So we've introduced a very nice feature called Explode Cabinet Design in RhinoCam, and it's available in our standalone product as well, which is called Visual CAD CAM. So when you select this Explode Cabinet Design, this displays the parameters that you can set for exploding into flat panels. You can choose to explode all visible geometries, and then you can basically place the components in a fixed direction. You could choose array along X or Y. You can specify the fixed distance in X, and then you can specify the spacing between each part. And you can choose to create both 3D geometries and 2D, or if you just want to create 2D curves from it, you could do that, and also place all of these curves on a single plane. And when you select OK here, this will automatically go through the process of flattening it out and put it on one plane.
Okay.
You see the powerful features where it automatically took care of converting it to a 2D, and also you have these dados right there, which basically runs all the way through, and you have these holes, you have these pockets in here, right?
So were these dados and things created inside SketchUp, or were they?
Yeah, they were all part of the 3D model. So what RhinoCam did was basically it flattened out those flat panels, and also extracted the boundary curves and the curves around the dados and the pockets and holes and stuff like that. So also it automatically assigns different colors for each of these features. As you see, they're all in different colors.
Right. Yeah.
So now you have these parts in here, but you would need to go ahead and nest these into a sheet, right?
Mm-hmm.
So that's where our nesting module comes in very handy for you. Now what we can do here is we can go to the nesting module, select RhinoCam and nest, and we go through the process of defining the different steps that are required in nesting. The first step I would do is define my sheet size. Most of the times it's just 4x8 sheets, right? Or it could be 5x10 if you have a larger sheet. So I'm going to define a 4x8 in here, and I'm going to start out by creating a rectangle, and that defines the extents of my sheet. And I'm going to go 4 foot along X and 8 foot along Y. So I'm going to set it to 48 by 96. So that defines the size of my sheet, as you see right there. Okay?
Mm-hmm.
Now we want to go through the process of nesting here. You could do a true shape nesting, or you could do a rectangular nest. Typically for CAB network you would be using a rectangular nest, and then you can choose the sheets. I'm going to click on select curve and just highlight the sheet we just defined, which is 4x8, and you can specify how many sheets you have on hand, the quantity of sheets. Or if you're not sure how many sheets are needed to actually nest all of these parts, you can just leave the sheet count as 1. We can estimate the number of sheets required for it. In the next step, we would like to select all the parts to be nested, so I'm going to use select curves and drag a window to select all of these parts in here, and then right click or press enter when done. And you'll notice that in this process it automatically groups them to parts, and then the holes or the dados that you see inside are grouped as child to each part. So they're automatically grouped based on the topology of the geometry. So we now have a total of 25 parts in here, and you can see automatically groups them as parent and the child. As you expand it, it'll show each of those features. Now you specify a quantity for it. So by default it's set to 1 because you just need to make one of these cabinets. If you need to change them, you can change the quantity and update all of them at the same time, or you can have different quantities for each, so you can set the count for it. So we have the part, we have the sheet set. Now the next step is to choose the parameters for nesting, so you can specify the distance between each part. So depending on the size of cutter you're going to be using, you can specify your sheet size to be distance between part to part. So if you're going to be using a 1/4 inch cutter, I may want to go like 300 thousandths between each part, or if you're going to be using a 1/2 inch cutter, I may want to go slightly larger, right? And then distance from part to sheet, the edge of the sheet to the part, I could only set it to 150 thousandths. You don't have to leave a lot of material from the edge of the sheet. And then you can specify any additional parameters, like you wanted to stack the result of the nesting, or you want to array them along X or Y, and you can specify the spacing between the sheets. And then if you select estimate number of sheets, it'll tell us that to fit all of these parts into the sheet, we would need a total of 2 sheets.
Okay.
And I can select update sheet count, and it'll automatically update the total quantity required. And I'm going to select execute nest. So this is basically computing the nest, and once you execute it, you can do a preview, and you'll notice that it shows the result into 2 sheets.
Yep. Okay.
Now we have the option to export each sheet to a separate file in here. We can choose a file name and select export. We can also move each sheet lower corner to the origin. So the lower left corner, the southwest corner will be automatically moved to X and Y origin. So if I choose export and choose an export path in here, I'm going to just go ahead and pick the desktop as my folder. I'll make a new folder in here. I'm going to call it sheet, cabinet sheets. And now I'm going to select export. This is going to successfully export them to the folder on my desktop. So now if I go to my desktop in here, I will have these files exported to it, and I can go ahead and specify the folder that I created in here and choose export. So this is going to go ahead and export them to the folder. So you'll notice that there's 2 sheets right in here, and I can go ahead and preview them. And you'll see that there's 2 sheets. So now let's go ahead and program these sheets. If you want to program each of these sheets as separate operations, we could do that, or we can process each sheet on the same file and also process it. Now you could also choose to commit the nest. If you just wanted to commit it right in here, I can select commit nest, and you'll see that the 2 sheets are right next to each other, laid out side by side, right? So if you want to program these 2 on just one file, I can select all of these and just go ahead and clear them out. So I'm going to go back to the mill module, and all I'm going to retain is just this information. And we have the 2 sheets laid out side by side, right?
Yep.
You could have had them stacked one below the other, or you can have them laid out side by side. So now you can program your toolpaths in here. So you typically want to program each sheet at a time, right? So you could choose the operations that you'd like to program. Say from the machining browser, you define the machine tool in here, and you define the machining process, whether it's going to be 3, 4, or 5 axis. In this particular step, we're going to choose 3 axis. In the next step, you would want to select your post processor. This would be the machine tool that you're going to be writing out the G code for. So the posts are listed either by the name of the machine or by the control name. We currently include posts for over like 225 plus different machines, so it covers a wide range of machine tools that are out there. And we could pick one of the machines from the list. So for example,
I think they're using Onsrud with FANUC controllers is what they're using.
Okay. So we'll go ahead and select, we have posts for CR Onsrud as well, machines, right in here. We can choose the OSI, AMC, or if you'd like to pick a FANUC control, I can just use the standard.
They're using the FANUC one, right. I know that other ones have used those, but this one's going to be FANUC.
Okay. I select the post processor in here. Now you can also notice that the sheets, each of these sheets are output as separate layers in here. So I could select the sheet and move the origin to 0, 0. I can pick the origin of the sheet and place it on 0. Okay? So we are now ready to process our toolpaths. So the first step in processing the toolpath after you define the machine and the post is to create your workpiece, the stock material. You can choose to establish the length, width, and height. Typically there are 3/4 inch height for the stock material. You define the height or thickness, and your stock is already defined right in here. We're now ready to program our toolpaths. I'm going to use a 2-axis, start with a pocket operation, and I'm going to select the features to pocket in here. In this particular step, I would like to pick the data right there, and there are this pocket right here, and then there aren't any, these are through slots, the data, so I'm going to leave them as they are. I'm going to pick a tool, so let's go with a 1/4 inch end mill, set the feeds and speeds, set the clearance, and specify the cutting conditions in here. Specify if you'd like to leave any side stock, specify your total depth. In this particular step, this pocket, I only want to go down 3/8. I'm going to put in the depth, break it up into 2 cuts, and then generate. So we now have a pocket
Okay.
operation program for it.
Yep.
The next step, I would like to go ahead and program these holes in here. Drill these holes. Go to hole machining, drilling, select holes and drill points. I can go ahead and drag a window to select all of these holes. So I select these holes, right click, and specify a tool. I would like to go with a 1/4 inch drill bit, and then specify the properties, specify the depth, 3/4 inch, and I would like to compensate for the tip, so we make it a through hole. So I select add tool tip to drill depth and sort them in a sequence and generate. So you'll now notice that the holes are being also drilled in a sequence.
Yep.
Now once the holes are drilled, we want to cut these dados or the through slots that you're looking at here. So we'll do a profile cut, 2-axis profiling, and I'm going to select them in pairs as you see it, right? There's one pair right here and one pair right here. I'm going to select a tool. We'll use the same 1/4 inch end mill, and I'm going to climb cut to the right side of these dados, so the directions are automatically alternated as you notice it right here. Cut levels, I only want to go 1/4 inch deep on the dados. We'll just do one pass on the dados cutting, and you can also sort them by minimum distance, generate it. So you can see that the dados are being cut in one pass. Now on this particular dado, I may want to use a larger cutter, or I may want to do additional passes in here. So I can go ahead and drop these two out in here and use a larger tool for the dado right in here. So you basically
Just 1 second. What? 1 second. Just 1 second.
Sure. So we just programmed the two dados in here using different tools.
Okay.
A 1/2 inch and then a 1/4 inch tool. And then finally we would like to cut out these profiles in here. We'll repeat 2-axis profiling operation, and we'll go ahead and select these profiles. So on the smaller ones and the larger ones, I can just drag a window to select all of these geometries.
Mm-hmm.
Select them all together. Use the cutter. We want to use a 1/2 inch cutter. Specify climb cut. I also want to use the midpoint of the longest edge for the location where the cutter needs to enter and leave the material. In the cut levels, we'll specify the total depth. So you want to go 3/4 of an inch. You'd want to go in like 2 steps. Specify lead in and lead out. You could do entry and exit. You could specify a ramp angle in here.
Okay.
And you can also specify a ramp angle for the exit motion. And you can enter in all the parameters in here.
Okay.
For the
Now, is
departure.
it possible to save these, preferences, like activate, if you're always using the same type of profiling for the outside, can you just call it up again? Or?
Absolutely. So what we're going to do is we're going to save them to a knowledge base. So when we have to do a profile, we'll just load the knowledge base and automatically profile those areas.
Perfect. Okay.
So here you can notice that the toolpaths are now programmed for all of these. Let's go ahead and run a verification. So I'm going to go to the Simulate tab. We have the stock defined in here. I'm going to select the setup number 1 and hit play, and that shows the material removal process.
Okay.
And the dados are being cut, the slots right there.
Yeah.
The final cutting of these. Now if you need to reorder the operations to minimize the tool changes going on in here, we could always rearrange the operation in the sequence that would best,
Sure.
describe the workflow. So if you select pause and simulate to end, it actually shows a simulation of all of these operations, the result of simulation.
Okay.
Now you notice here when I right click and go to information, we have different tools being used. We have a 1/4 inch end mill, we have a drill, then a 1/2 inch end mill, 1/4 inch end mill, and then a 1/2 inch end mill. So we would like to minimize the number of times we want to change tools, so we would like to reorder it. So we could probably start using the drill first, the 1/4 inch, and then go to a 1/4 inch end mill, and then do the 1/2 inch end mill at the very last. So we can go ahead and reorder it by just simple drag and drop. So we have the drill operation first, and then we have the pocket operation, and then we reorder the dado operation with a 1/4 inch. So now when you after reordering it, if you take a look at the information, you're going sequentially, there's only a total of 3 tool changes occurring in a sequence.
Mm-hmm. Perfect. Okay.
And you can also get the estimated time for machining in here, right?
Okay. Yep.
Okay. Now that we programmed this part, we are ready to output this to the machine. Right click and select post. You can choose a folder, and there's your posted output file.
Okay.
Now this
Perfect.
program is ready to be transferred to the machine. So this is the program that you generated for sheet 1. Now I'm going to show you some very nice features where we have built automation so you can actually take this entire workflow of operations that you programmed and you can save this to a knowledge base.
Okay.
And I'm going to choose a folder under the data folder. I'm going to call this cabinet sheet 1.
Okay.
I now have this saved to a knowledge base. Now let's go ahead and load one of our other sheets in here. So I'm going to go drag and drop and bring in a new drawing into it. And this is all we have is a whole new sheet as you see it right here, right?
Mm-hmm.
So we have a whole new sheet. Now I would like to program the toolpaths on it. So first step is I'm going to establish my origin, align set world coordinates and the southwest corner. So the part is now placed at the origin. Okay?
Mm-hmm.
Now what I'm going to do here is show you how we can take advantage of the knowledge base that we defined from the previous steps. So I'm going to go ahead and click on load knowledge base and grab this cabinet sheet knowledge base right into it.
Okay.
So in this particular step, it brings in all of the machining operations. So all the parameters that you programmed in here are automatically in there. The tool, the feeds and speeds, your clearance, your cutting conditions, they're all in here. All I got to do is select the geometry. So for the drill points, I can say select drill points and circles, and we are using Rhino. I'm going to use select objects based on color. I'm going to click on this, and this will automatically select all the objects of a given color. I can go back and also add additional points if I'd like to. So you can see that these two objects are in different colors. One of them could be a through hole. The other one could be a partial hole, like a pocket, or like a, where you have these pins that you need to put in to lock things into place, right?
Sure.
Like dowel pins. So you can select them and generate your toolpaths. Now I could make a copy of this operation. If I need to make changes and have a second copy of drill operation, I can do that, copy and paste. And now I can go ahead and edit this operation and now select drill points, use select by color, and you can notice that all of these holes are selected. I can change the depth to only go 1/2 inch and not add any tool tip to drill depth. So these are partial holes that you're drilling right now. So one of them you have through holes, you have partial holes, right?
Yep.
Now for the pocket operation, you could use the same workflow. Select the curves, select these curves, right click, generate. Okay? Now finally, the profile operation for the dados. I'm going to click select curves and go ahead and select these curves right in here for the dados and generate the toolpath. And finally, for the profile for the outside cuts, I can choose the operation in here. Now before I do the outside cuts, I also need to program the larger dado right there and generate it. And finally, we would have to do the profile cuts on the exterior. We just go ahead and select these either by select by color, or I can just drag a window to select all of these objects in here and generate. So you can notice that the first part we probably spent 5 minutes to program it. The second part we are just spending less than a minute to select just all the features and program this part. So now when I define my stock geometry in here, all I got to do is go ahead and run a verification to make sure everything looks all right. So while the part is cutting on the machine, the operator can quickly program other parts and have them queued up so it's ready to be machined. So the minimum amount of time he's spending programming the toolpaths in here.
Yeah, understood, yeah.
So I'm going to select pause and simulate to end. That runs through the simulation.
Yep.
And then post-process will generate the posted output file. And there's the output right there.
Okay.
Now I want to show you one more level of automation that's built into the product in here, where we can actually set up rules to the knowledge base. So rather than having to go through the process of selecting these curves or sketches in here, we could establish a rule for the knowledge base so it can automatically select objects based on certain properties like certain colors. We can establish them to select the objects.
Can you use different layers?
Absolutely, we can do layers as well.
Okay.
Now I could go ahead and create multiple layers in here, and I'm going to say layers, first call it cutouts, and I'm going to call this holes. I'm going to call these dados, pockets, right? And I can define different layers in here. And now in Rhino, I'm going to select objects based on color and place this on layer called cutouts. I'm going to use these pockets in here and move all these 3 pockets into a layer called pockets. I'm going to select the dado right in here. I'll put it on layer 5. And the smaller dado, I'm going to put it on layer dados.
Okay.
And I'm going to call these dados large. And finally, these holes that I have in here, I can select all of them. I'm going to place them on layer name called holes.
Okay.
So we now have everything structured into different layers, right? Now when we set up rules, we can assign selection rules to automatically select. For the drill, I would like to pick all the holes. For the pockets, I would like to select by layer name pockets. For the profile, this is for the smaller dados. I'm going to select the smaller dado layer name. And I can use select by color, select by layer. I'm just using select by layer for all of these. And finally, this one would be called layer cutouts.
Okay.
So I established rules in here. And now I'm going to save this knowledge base again. I'm going to call it with rules. All right?
Yep.
Now let me also go ahead and export all of these back again. I'm going to select this, export it. I'll put it in the folder on my desktop in here. I'll call it sheet 3. Okay? I'm going to go ahead and open up sheet 3 and not save any changes in sheet 2. Now, all I'm going to do is define my stock and load my knowledge base, the sheet with the rules I've set up. And all I got to do is right click and generate. I didn't have to pick any geometry. Everything is automatically selected based on the rules that you established for the layers. So for your operator who's going to be programming repetitive stuff, loads the new drawing, loads the knowledge base, right click and generate. So 3 steps and you have the toolpaths ready. And you can go ahead and validate all of these by running a simulation. And you can also speed up the simulation in here. Shows all of the processes right there. So this is how you can automate the entire workflow, and it's a great tool for when you do cabinet work.